All right, good afternoon, everybody, and welcome to RailPulse's fourth webinar, Turning Data into Action. I hope you all had a great summer, and we're excited to have you be back with us in today's session. And we're going to be focusing on challenges that we all share. It's how to make our data work for us. Just a friendly reminder that this session will be recorded and will be uploaded to our YouTube channel. So if you want to see a replay of this or send it to your friends, we will share it after this call, and you guys will have access to it. So today's agenda is going to be simple. We're going to go over data curation visibility rules, access and integration RailPulse data, and then we're going to do a Q&A section at the end. So if you have any questions, just go ahead and type them in the chat for us, and we will cover everything at the end. Now, let's hear from the person who we're really here to hear, and that's Matt Wood, who's our driving force behind RailPulse product and platform information. So I'll let him take it away. And
thank you, Anna. So your teams need easy access to high quality data to succeed, which is why you're all interested in telemetry data. That's why you're here talking to us today. For your company to extract the most value out of telemetry, you need a single curated vendor neutral data set incorporating device health and trust. My name's Matt Wood. I've been in the rail industry for over 25 years. I've been here at RailPulse for the last 2.5 years. I'm the director of product management, so I'm in charge of our product, everything from data ingest, working with our vendor partners, processing data data out to you, whether that's the portal or APIs. I'm really excited to show you the options RailPulse has for delivering curated data to your teams, enabling your operations to be based on facts, not guesswork, giving you higher quality data than you've traditionally been able to get within the industry. Before we jump into how RailPulse can share data, let's first talk a bit about the overall data structure and data architecture for RailPulse. RailPulse receives data from any of our certified vendors through a standardized format that we call the RPI-TSS. So as we add more certified vendors, we ingest that data into our system, where we combine it with other data sets to enrich that data. So we get data from areas like RailLink, where we get UMLR, CLM, and waybill data. We have other data sources as well, where we're pulling in geocoding, weather, things like that. All of that data comes into our system where we process it, curate it, validate it, and get a good solid data set before that data then goes out the door. Before we make it available in any way, it has to pass through our data access and security level. So we have a data visibility scheme that our membership has voted on, that all data goes through to ensure that we have proper security in place so that only the proper companies are seeing data from the devices. Only at that point do we then make that data available out through our portal, through our APIs. You can see here as well, in the future, we anticipate sharing some of this data through RailLink as well. We work with many of the committees within the industry, committees such as the MOATS committee, where we're looking at how do we share level 1 data, level 1 alerts through RailLink to the railroads directly in the future. So we'll take a couple, we'll go through a few of these areas in the next few slides, kind of talking about each of those areas in a little bit more depth. First of all, what data does RailPulse collect? Right? In short, our platform has really been designed to accept any data that sensor vendors can record, whether that's state, status, or event data. It's an open architecture so that it's easy to expand upon. The RPI-TSS is easy to expand upon as well, making it easy to evolve as the industry continues to evolve. Currently, we're working with data such as GPS location, movement state, whether your car is moving or idle, load empty handbrake states, open close for doors, hatches, or gates, wheel health that comes in terms of kips and dynamic kips, shock impacts and G-forces, temperature and brake slides. If you want to see more about that in detail, we've done multiple webinars in the past that are recorded and available that kind of show you the demos of the system, how we record those states, what it looks like in our system. So I'm not going to spend a lot of time on that today, but those are the main pieces of data that we get from vendors today and record. we're constantly working with our vendor partners as well as they continue to develop new capabilities. So if a few of those that are coming that we are working them on with them are track level visibility. So our current positions have about a 30-foot radius of accuracy. We're working with multiple of our vendor partners to have a track level visibility down to 7-foot radius so that you can tell exactly which track, which spot your car is on. Load state percentage is another one so that you don't just know if the car is loaded or empty. We can give you an idea. Is it partially loaded? Is it fully loaded? Is it overloaded? Bearing health in terms of temperature or acoustics, brakes and system health monitoring, and impact speed. We see speed of impact as being a very valuable thing so that you know how fast the car was going when it got hit. So
Hey, Jason.
this is the type of data that we're recording now and what we anticipate coming up. Go ahead, Anna.
Yeah, Jason, I see that you're on the call. Can you explain how does JTX uses data from the APIs to RailPulse?
Yep. So happy to join. Just as quick introduction, I'm Jason Ormond from GATX. I've been working at GATX for about 12 years and oversee what we call our emerging technologies function. So essentially all things sensors on rail cars. And in terms of how we use the data internally, we pull it in through an API. And one part of what we've been doing with the data is to use it as part of analysis and compare it and merge it with our own, we've got years and years of maintenance repair data and see what kind of equipment health potential lessons, avenues for cost savings by looking at the impact data, by looking at some of the wheel set and health data from the brakes, from the handbrake sensor. And at the end of the day, these are super expensive assets that are worth a lot of money. And if we can figure out a way to better maintain those assets, there's probably a real ROI behind it. So we're putting a lot of effort there. And then separately, for the teams that already have the tools that they use today. So for example, we just rolled this out to our sales team. They've got various different reports in Power BI that merge together some of the car specific information as well as customer information. And really all we did was add a really, 1 or 2 columns that gives you or gives them a quick flag on, does this car have telematics? That way they know quickly, getting ready for a conversation with a customer, they can get a quick read on which leases are applicable and which cars and what's the health of those devices on those cars. And then the whole separate conversation that we haven't really touched on here is how we're doing this externally with that data feed with customers.
Jason, do you have any examples of how you're doing that externally, or is this something you're still working on?
Definitely still working on it, but we do have some examples, fortunately here recently. What we're leaning into, and I think others across RailPulse, but kind of leaning into the open and neutral foundation that RailPulse has set, where with this data feed, we really don't care where it goes. And we've got at GATX certainly lots and lots of customers who've got TMS, transportation management system tools, so software providers that provide solutions to them today where they interact and do all kinds of things like create waybills, manage their own maintenance information, and just overall manage their fleet. And so what we're trying to do is, as the fleet of cars grow that have these sensors that provide far more timely information and more frequent updates than you get typically historically on your rail cars today, get it into those tools that our customers already know and use, and they don't have to go to separate logins or even to separate websites to get updates on the progress that a car is having on a route. And so we just within the last couple weeks announced a partnership with our mutual customer NGL and their TMS provider Geometrics. And so again, what we're trying to do here is to get this new information and provide Geometrics with an opportunity to enhance their product suite and hopefully extend those lessons and services to other customers they have. And then ultimately, I think we've got a few other customers and their 3PL providers that seem to be really interested and engaged, and hopefully we can do this more and more. And if we can take this data and make an environment where it's easy to get devices on cars, you can trust those cars, and you've got data flowing to all the right people, the railroads, lessors like us, the shippers. Ultimately, I think you can take this technology and hopefully make it easier to ship by rail. And if we can do that, then everyone's going to benefit.
Perfect. Thanks, Jason. And Matt, I have a question for you. For the ETAs, for the 7 locations, are all the vendors working on it, or is it just one? Can you give us a bit of a background of who's
for track level? Oh, sorry. For track level GPS.
Yes.
Yeah, we have multiple vendor partners that are working on track level visibility at this point. It's not all of our vendors, right? Each of our vendors has different areas that they're exploring, they're expanding into, but we have at least 2 vendors we're working with now that are working on track level visibility. We're hoping to see that start to become a real thing at the beginning of the coming year. So moving on, RailPulse doesn't just collect and redistribute data, right? Our goal is to curate data so that our customers can trust what they're receiving is high quality, and you don't need to invest your own team's time in doing validation of the data, right? We want to do that work for you. We want to monitor the devices, monitor the vendor data flows, do that work for you so that you can concentrate on using that data to get value versus validating the data itself. So we do that by pulling in all of the raw data from the vendors, the telemetry data, combining it with data from RailLink, Waybill, Seal, and Umler, pulling in other miscellaneous data like the weather and geocoding. All of that then gets processed real time through our system. We run it through a set of validations where we're validating things like the schema. We're deduplicating data. So if we're getting duplicates of data, we're making sure those get curated out. We handle out of order and non-chronological data. Not all of the data you get off of these devices comes in a nice, clean, easy data flow that's chronological. So we handle all of that kind of complexity of taking out of order data, taking the non-chronological data and making sense of it, lining it up appropriately. We're also working with vendors to take in data corrections. So multiple of our vendor partners will realize that a value they sent previously was incorrect, a position may have been incorrect, and they'll send a correction to that. We handle taking those corrections in, revalidating that, making sure that that change didn't change other aspects of the data as well, and pulling that into our curated data set. We're running all of those things through. Oh, you can go back one through the rest of our data validations, making sure that the vendors are sending data to meet our cadence requirements and other requirements we have in place for them. That clean data then gets used to evaluate geofences, auto fleeting, state changes, and then feeds into our trigger evaluation where users can set up trigger rules to alert when a certain thing is seen. The outcome of all of this is our cleaned, curated data set where we have distinct positions of rail cars. We know the state change times, when exactly did the state change, what the sensor values were at different times, and what events have come in. We also end up with a set of geofence entry exit data that's clean, and then device health. Device health is really important. So we're using the data that's coming through, validating against our latency and cadence standards to determine, is that device still healthy? Is the device sending good data? Is it online, sending data still? Is it overdue based on our cadence requirements? Or is it now even offline where it's been overdue for so long that we now consider the device not trustworthy? We also pass that same device health data over into our operations team. They use that to look at things like jitter, high jitter, where devices may potentially have been installed incorrectly or have some damage to it, and use that to go then do investigation with our customers, do investigation with the vendors, And if we identify that there's a real problem with that device, that goes back into our device health data. That's part of what we then use when presenting data through our portal or APIs to you as a customer to not just tell you what the state of a device is, but also tell you, should you trust that data? Is that data trustworthy or not? All of this together, our process curated data, then leads to being able to provide high quality alerts based on the triggers that you've set up. So now we have data that's come in, we've processed it, we have a good clean data set. We now need to make that data available to the proper companies. So the RailPulse Coalition was really founded on the principle that data transparency will drive service and safety gains throughout the rail industry. We share our curated data based on a set of visibility rules that our member board has approved. So RailPulse doesn't make up these visibility rules. These are rules that we implement based on our member boards voting on what they want to happen. The rules are similar to RailLink's rules for sharing CLMs and waybills, though they differ a bit because we have an expanded set of data that RailLink doesn't really have to deal with. Data security is really core to what we do. It's core to our mission. It's a foundational aspect of our systems. We believe in sharing data, but sharing data very safely. We don't want to accidentally give data to the wrong party. There's a lot of data here on this slide, but I'm going to just kind of summarize it really quickly. We have 4 types of data, 4 data sets that we can share. The first and the most important is the subscriber data. So the subscriber is the company who installed the telemetry equipment on the railcar. Right? So if you buy the equipment, you put it on the railcar, you would become our subscriber. You own the telemetry data. RailPulse has no ownership of this data. We are just the custodian of that data for you. So the subscriber gets all telemetry data. We break this data down into 2 different aspects, approved elements and experimental. Approved just means that our member board has reviewed the data, the quality of data coming in from the vendors, and has approved that data for sharing. Experimental is data that's still going through that process. It's data that we're working with vendors on. They are bringing new devices out. It has not yet been validated and approved to be shared, so it's experimental. Experimental data is always just available to the subscriber, or if they have the option to share it through a fleet LOA with someone else. The important part of this is that you can work with a vendor on a new type of device, and that data is going to be experimental, and you don't have to worry about it getting out to other companies, being shared in ways you don't want, because you're still experimenting with it. Since we're still evolving the industry with the vendors, we want you to have that data available so you can use it, you can evaluate it, but not worry about it getting out into the wild. So that you can see the experimental data is very locked down. It's just for the subscriber. Once you go past the subscriber data, we have 3 other sets that we'll go over really quickly. Service data. So a subset of the data elements for promoting service within the industry are approved to be shared by 2 parties on the waybill. So you can set up a waybill LOA with RailPulse. If you then are a party to the waybill, you're the shipper or consignee, then you would have access to the service data, GPS, impact, load, for the duration of that waybill. In a similar way, we have safety data. Safety data is a different set of elements that are made available to railroads, class 1s or short lines, who are in the route of the waybill. So if a railroad is helping move that car for the duration of that waybill, they get to see the safety data to help promote safely moving those goods and getting your car there as efficiently as possible. Lastly, we have owner data. Owner data is kind of a real edge case where the owner of the car is not the subscriber. And most likely this is happening because a lessor has not put the equipment on the car. They've given the lessee permission to equip the car. And in that case, the lessee is the subscriber. They own the data, But because the lessor owns that actual car, they're in it, Umler is the Umler owner, they get a small subset of data so they at least know the position of the car and have some basic information about it. It's similar to how the owner in Umler always has availability to see the CLMs in RailLink. The result of all of this is that you not only have access to all of the cars you equip, but you also have access to any car where you're party to the waybill that another company is equipped, right? So one of the benefits of working within RailPulse that as telemetry grows, as more and more companies add telemetry to their systems, if you're using mixed fleets, if you're using system cars, you get visibility to those cars from one data flow, one source versus needing to go out to multiple places to get that data. So now we have, we've talked about all the data that we collect. We've talked about how we validate and curate that data. Now we actually talk about, how do we make this available to you? This is what you've been looking for today. We really have three main avenues for sharing data. First is our portal, right? We have a web-based portal with reports that are ever growing that are available through it. Every company has access to the portal. There's no additional cost for doing so. It's kind of the first entry into the system. The no technical integration, we have SSO in place that we can set up with your company if you would like, so we can federate with your company so your users don't need to have credentials within RailPulse. They can just access the site and get in. It's always available, so you can always use it. The two other main ways we have for sharing data. We have a set of pull APIs. So we have pull APIs for both our current and historical data. You can query a list of currently visible cars. So not just your subscribed cars, but if you're using system cars or if you're on the waybill, you can query to see what all cars do you have visibility to at this point. You can query for one or more cars the current state of those cars. So you know if they're loaded, empty, handbrakes on or off, what the temperature readings are, any other information that would come in as from the vendors for those cars. We will send you the latest known value for everything for that car. Or you could query historical events where you can go in and for a given car, query all events for a time period. I want to see all of the things that have happened to this car over the last 7 days. We'll return all of that to you. Additionally, we have the ability to stream data to you. So we can stream data out, pushing data to you in a near real-time way. There is a bit of a latency. There's a bit of a latency for the vendor to process the data and get it to RailPulse. We then add a bit of latency under 30 seconds ourselves for the curation, processing, alert generation that we talked about earlier. But as soon as that data has been finished processing or an alert has been generated, we would stream that out where you can then consume it. So streaming is by far the quickest way to get data from us.
Thank you, Matt. Hey, Joseph, are you on the call?
Yes, how are you?
Hey, good. Can you just introduce yourself real quick before I have a question I want to ask you?
All right. My name is Joseph Cowper. I'm the Director of Fleet Planning at Norfolk Southern. I've been with Norfolk Southern for 16 years, and my main area of responsibility now is the long-term fleet planning of our railcar fleet, as well as how technologies are coming into our distribution systems.
Can you explain how APIs reduce manual handling and speed up expectations?
So in conjunction with the portal and the APIs that are currently streaming into Norfolk Southern, we're using the data to enhance our already internal facing metrics. We're placing the APIs data into these reports, and we're enhancing it with near real-time accuracy of where cars are located, their current states. We've had a couple of instances where using the alerts that have been built in the portal, we're able to catch issues before they actually become issues. And we've been able to take that to our customer service folks who are responsible for dealing with these issues and bringing them to light with the customers and correcting billing issues to ensure that cars are routed properly and not delaying any shipments that would cause delay for the customers on either end of the shipment.
Great. Thank you for your input.
So before we talk more about our different APIs, I just wanted to take a moment to talk about what the data looks like when you would get it. We're not going to get down to the field level, but at a high level, all of our data is formatted in a common schema. It's an event-based schema. It's all JSON-based, where we get data. We're going to send you information for a rail car at a specific time. So an event is something happening to that car at a specific time. We then use a common structure that includes the position, state, sensor values, including shock data, alert data that includes trigger. We will then populate the pieces of this schema based on the type of data we're receiving and sending on to you. So you don't need to have a bunch of different interfaces in place, different data structures to interpret. There's one common structure that we then repopulate based on the appropriate data coming through. This was done to try to simplify the data. It's much easier than the ITSS where we're getting data there, where there's a lot of different formats and different ways of putting the data together. This is a nice streamlined way of sharing data. It makes it easy for us as well to expand on it as we find new data aspects that we want to share. So let's talk a little bit about push and pull. I'm going to talk a little bit about why you might use one versus another, what the options are good for. I'm not planning right now to talk really in depth about what the push and pull technology looks like, though if that's something you're interested in, please, when we get to the question and answer, speak up and we can speak much deeper to that. In terms of which of these to use, pull APIs are really good when latency is not a factor. When you don't need the data to be near real time, you don't need it to be coming to you really quickly. It's best for ad hoc type queries, right? Where you need to query for a set of data for a specific purpose, but you're not doing it all of the time. Or if you need to do kind of scheduled syncs or historical data pulls to pull in for your analytics or reporting systems. And it's also really good for system integration, right? If you have a transportation system or other system within your company, a customer service system that you've built, and you need to be able to just pull data for a specific car when someone goes to that car in your system, so you can layer the data together. Pull APIs are ideal for that, right? You don't have to get data for every car all the time. You just pull the data you need as you need it. Our push streams, our push APIs are ideal when you need real-time data. You want to know status changes quickly. You want to get alerts very quickly. These are really important if you're using this data operationally, right? If you have sites where cars are coming on site, your people need this data in their hands quickly so that they can make decisions, then we would suggest a push stream where we can push that data to you. That way there's very little latency. You get it quickly, you have it immediately. Push streams tend to also be really good when you have very large fleets of cars, where pulling lots of data at once can be kind of resource intensive. The push streams are nice because it just is a trickle of data coming through all the time versus one big hit of data. We at RailPulse don't really have a preference for how you get data. Our goal is to get the data in front of your people in the best way possible. And that may mean using just a pull, just using the portals, or it could mean a hybrid approach where different teams have different needs, right? You may have one team where just giving them access to the portal and they can just go in and query ad hoc when they need to is all they need, and you don't need to do any work. We have another team that's more of a data analytics team, and being able to use a pull API to pull our data in, incorporate it in their data sets brings real value. We're good with that. We work with each customer to come up with the best approach for their situation. whether that's one approach or all three approaches. We will work with you to make sure that you're getting the data you need. As Jason mentioned earlier as well, that might mean pushing your data not just to you, but to your software partners. If you have a TMS or 3PL that you're working with and you need the data sent to them, we'll work with that company to be able to consume your data stream or give them access through your credentials to the pull APIs.
And I know we have Pete Corbett from Greenbrier on here. Hey, Pete, can you hear me?
Yep.
Hey, can you just introduce yourself real quickly and explain how device health and certifications improve reliability?
Sure. So my name is Pete Covert. I'm with the Greenbrier Companies. I'm the Director of Digital Solutions and Automation. We've been a partner with RailPulse from the very get-go. And I want to talk a little bit about one use case we're seeing here that's really paying off for our use in RailPulse. I've been in the industry for about 30 years, and it's really exciting to finally get to the point where we're getting telematics from our rail cars. We've talked about this for decades, and to actually be at this point where we can take advantage of this data is pretty exciting. So the scenario I want to talk about today is a case where our engineering department is considering some design changes, and they want to try a few things in terms of how we build rail cars and understand what impacts those changes have. So we are interested in using sensors on the cars to get us some additional data and understand how these changes are impacting the performance of our rail cars. I'm going to get a little technical here since I'm on the tech side of things. We are an Azure shop, so we use a lot of Microsoft products. RailPulse is using AWS, but the integration to RailPulse for us has been super simple. We've been able to integrate painlessly there. We are streaming the data. Matt was talking about the push versus pull data. We are getting near real-time data into our analytics platform through the streaming option, and it was very easy to set up. Some of the benefits we're seeing is from the engineering perspective, they're very excited to have real world data. Instead of having to test these changes in a kind of experimental lab scenario, they can put these rail cars on the tracks and understand if they're performing a little bit better, a little bit worse than they were before. So we can iterate much more quickly, and they're seeing this data in real time. It's it's amazing how much of the world still runs on Excel, and to have people see real-time data show up as they're trying to do their analysis has been pretty mind-blowing for the engineer. So they're very excited about that. From the IT perspective, from the technology perspective, really getting this data into our platform was a low code or no code type of scenario. We were able to configure things on our side, pass the necessary information to RailPulse and have them set up the configuration on their side, and the data just started showing up on our platform without any coding on our side. Matt's mentioned before that they are really consolidating all these vendor data streams from different vendors, different sensors, and making it all a unified stream. And so that has saved us a huge amount of work on our side. I'd much rather RailPulse figure those challenges out than my team having to figure that out. So it's really great to get this nice, clean stream flowing to us. And the flexibility of the stream is also quite impressive. In this case, we are using an experimental sensor that falls into the experimental chart that Matt was showing earlier. And we hadn't been using this sensor before, and when we added it to these rail cars, that data started flowing automatically without us having to make any changes on our side. So it was great to have that flexibility in the platform. So this is just one example of how we're using it. I think we're just kind of dipping our toes into what's possible here, but we're extremely excited to see where this goes next.
Thanks, Pete. Yeah, the more cars you equip, the more data we have to play around with.
So one last aspect that Pete just actually kind of hit on that I wanted to spend a few minutes to talk about is vendor interoperability, right? So when you work with RailPulse, there are some different benefits to getting data in. RailPulse is really a vendor neutral area. As long as we've worked with a vendor and certified that we trust the data they're getting, we'll take their data in. We do that hard work of validating the data with them, processing it, making sure it looks good, and trying to make the data between vendors look apple to apple when you're looking at that data, right? This can be important to you for a couple of different reasons, right? So if you're a company using system cars, those system cars that you have access to through RailPulse may not have been equipped with a vendor that you had decided to equip your own cars with. right? Because we take all that data together and make it apples to apples, you can get one data stream regardless of what those other cars were equipped with. If you're buying and leasing cars, right? So if you're buying and leasing cars from multiple different companies, those different companies may have picked different vendors than you would have. And so as your fleets age and you're buying new cars to add to your fleet, or you're leasing, one lease is up and you're leasing a new set of cars, you don't need to worry about what vendor had equipped those cars. We'll handle all of the data for you. If you have a diverse set of cars and you have different types of cars, you may find that different vendors have different strengths in different areas. So one vendor may have really good temperature gauges for your tank cars, but another vendor has really good, gate sensors for another set of cars. You can use the type of devices that make sense for the types of cars you have, not worry about multiple integrations into the data for each of those vendors. And then kind of lastly, you may be just kind of coming into telemetry, kind of experimenting with new, you want to dip your toe in, you're not quite sure which vendor you want to work with. You can work with multiple vendors up front, test out different sensors, buy 50 of one vendor, buy 50 of another vendor, try them out for a while. We'll feed that data to you, help you understand how those different vendors are performing on your cars before you fully commit to which direction you want to go with your entire fleet.
And I know we have Kylie from Union Pacific on here. Kylie, can you just give us a brief description of yourself? And then I have a few questions I'd like to ask you.
Absolutely. Happy to be here today. So I'm Kylie Freeman. I've been with Union Pacific for 16 years, and I am the General Director of Transload and Logistics at Loop Logistics, which is a wholly owned subsidiary of UP. And so my responsibilities are both to manage our North American transload network. So I get to be a customer of the railroad as well as work for the railroad. And then we also manage thousands of rail cars a day through our monitoring services, which uses Shipment Vision, which is a platform I'm excited to talk about our integrations with RailPulse in.
Perfect, thank you. I know that UP uses 3 out of the 4 vendors that RailPulse works with. Can you just talk about how, what the technical hurdles UP faced when integrating with RailPulse?
Yes, absolutely. So at UP, we've been investing in visibility and really thinking forward about integrations for several years, which has been exciting to be a part of as we've developed out APIs and different ways for customers to visualize their traffic. When integrating with RailPulse, we appreciated the support to make sure that that was a relatively seamless process. And frankly, our teams, when I talk with our tech organization, they call it a smooth integration. And we're very appreciative of both the support that they got and the ease of integration. What that's now allowed us to do is we push that further into our technology platforms so that our customer care team now has that readily available through all of their operational data. And we also have it fully integrated into our Shipment Vision platform, which is what our Loop team uses to make sure that we can see customer traffic across the network. I loved what Matt talked about earlier about making it actionable. Having those integrations has really allowed us to make this an actionable product.
Perfect, thank you. And then how did the standardized schema simplify deployment across multiple vendors?
Oh, absolutely. I mean, standardized schemas, they really do help us make sure that we have clean data. It employs that trust, and it just ensures that we don't have to ask all sorts of different questions as we do that together. It's interesting to see as this information has evolved. So we've had GPS on containers for several years, and we've seen, the undeniable truth that it really has improved a lot of our metrics, including dwell, versus containers that do not have that product. And so things like schemas that allow us to make it easier to integrate are very, very exciting. What we're really excited about now on the RailPulse side is just building out that density so that we can answer more and more questions and help prove out those use cases.
Thank you so much, Kylie. Thank you for joining us today.
Absolutely.
So kind of bringing this all together, RailPulse is structured to be a nonprofit company. Our job at RailPulse isn't out to just go make as much money as we can. It's really to promote the use of telemetry data throughout the rail industry so that all of our companies can grow together. We work closely with all of our customers to ensure that they're getting the maximum value from their telemetry investment. There's no one use case that justifies telemetry for all companies. right? Each of our companies will likely have multiple uses of the data, whether that's driving operational efficiency, enhancing customer experience, driving predictive maintenance, or helping with compliance and safety. We here at RailPulse are here to help you succeed and plan to continue expanding our capabilities based on your needs. That includes expanding our APIs, building new structure, building new reporting, adding to our portal. I hope that this overview of our curation, our visibility schemes, how we can share data has been helpful, and want to thank you for your time today. We're, we're now kind of open for questions. So if you have questions for us about how our sharing works, what the options look like, what would be best for you, please speak up or send those in to Anna.
I do have a few questions, Matt, that were asked kind of in the beginning, and I just want to wait till the end to make sure that they were answered beforehand. If not, I would kind of follow up. Karina asked, is the load state percentage be additional information out of the load empty sensors, or is that going to be an additional device that you'll have to install in your car to get that information?
The goal with that is to drive that data from the existing load state sensors. Each of the vendors is looking at it in a slightly different way, but the goal would be to be able to give you data based on existing sensors where they're interpreting the data they're already getting to a higher level to give you a percentage. Now, the load state currently won't ever be, or won't, at least in the short term, be a specific percentage. I probably won't be able to tell you it's 96% loaded, but we're hoping within kind of 10% gradients. This is 80% loaded, 90% loaded, 100%, or 110 or 120. So you can tell it's overloaded. That's what we're looking for up front. There are some additional load empty capabilities some of the vendors are looking at to look for shifted loads or uneven, unbalanced loads. Some of those may require more than one load device per car. So if that's something on a subset of your cars you're really interested in, it might require a load sensor at both ends of the car so they can determine that it's a shifted or unbalanced load.
Yep. And somebody asked how many rail cars we currently have in the RailPulse portal. So RailPulse currently has over 22,000 rail cars in our portal, which means that the more you equip, the better information that we get. Tim, I see that you're on the call. Welcome. Thank you for being here with us. Tim is our operations director, and I do have a few questions for you. Can you talk about the pricing structure of RailPulse and what does it cost to be part of the RailPulse? Somebody was talking about the subscriptions versus investments, and then the service data cost.
Sure, absolutely. And thank you very much for allowing me to address those questions. The number which you identified on that is not what it costs to join RailPulse by any means. Generally, it costs between $700 to $900 per car for the hardware. And that also includes a 5-year subscription should you have a 5-year prepay subscription. So it is generally about no more than $200 per car per year over the course of 5 years. With respect to the other question regarding access fees, you can receive the service data. If you're not a subscriber, you can get a waybill LOA in order to be a part of that information that is shared with you via the subscriber. So it is the subscriber's data, but they can opt to share it with you through a waybill LOA. And Matt, correct me if I'm wrong on that, or if you need to add any other things to it.
That is true. So if you are on the waybill but you're not a subscriber, you can get to that data through the portal for free. So if you want to just log into the portal and see the cars that have telemetry devices on them and you're on the waybill, you can work with us to get a subscription agreement in place. That subscription agreement doesn't cost anything. You can then access that data for free through the web portal. There's no cost at all. There is a slight cost for our API data. We're not a for-profit company, so we are just trying to cover our cost. So there's a slight cost for providing that data through an API. It's somewhere on the order of 16 cents per 1,000 events. So it's a relatively small number. Just to, again, We have to get the data out of our cloud provider. We're just covering the cost of exporting that data to you.
And Larry, I see that there's a question with respect to the tank car data. That information is also available through RailPulse, and the cost for that service is similar to what I just mentioned relative to that. We do require that each of the cars with an installation have a GPS gateway on it, as well as a load empty detector. And if you have a temperature sensor on that, that would be a smaller charge on top of that for the hardware, but not for the data. That the data is inclusive in that cost which I mentioned. One other thing is that Anna mentioned the number of cars we have in the portal as of right now. We anticipate having about 35,000 rail cars by the end of the year, and with aggressive plans for next year, as well as commitments.
See a question from Peter around whether we're only involved with rolling stock or also with infrastructure sensors. We do not currently work with infrastructure sensors. All of our sensors are based on either rail cars or locomotives. We do have locomotives that are being equipped as well in the system, but it's all rolling stock to date.
Thank you, Matt. Thank you, Tim. Does anybody else have any other questions? If not, you guys can always reach out to us through our website or send us an email at RailPulse, and we'll happily answer any questions you have. So
I do
thank you.
have a question. I apologize. The curiosity of numbers, I wanted to see, do you guys have a number range of how many RailPulse devices are now added to rail cars across the United States? Do we have a number or figure right now?
Yes, Basia, we just answered that, but I'll repeat it. We anticipate having 35,000 rail cars by the end of the year. Currently, we have about 22,500.
Thank you.
You're welcome.
On behalf of RailPulse team, we say thank you for joining us, and we look forward to seeing you soon. I will be sending out this recorded webinar to all of you, so don't worry if your teammates missed it. You guys can always send it to them, and we'll be on YouTube and our website. Thank you all so much, and you have a wonderful day.
Thank you all.
Thank you, everyone.